So here let's go to next question. Problem 7, right? So find the interval of convergence of each of the following power series. So first one is this one. So it is convenient, I think, if you use, so here 1 over 3 to the power n squared, you can get rid of one of n's. So by using which one? Root test. Alright. So here we use nth root test. So always you have to consider modulus, because otherwise this becomes negative, because we don't know the range of x. That's why you use nth root of modulus of that term, right? So this one. So when you take the limit of this sequence, you get 0, right? Whatever x value is, so you get 0 all the time. So that means that series, that power series, is convergent for all real numbers. So the radius is infinity. Infinity. So the interval of convergence is r, because so whatever, when you put any values here, the limit of this one is equal to 0, right? Now let's look at the second part. Here exponential of square root of n. Let's use ratio test for this. So from ratio test, put this modulus sign, right? Modulus mark, otherwise, because here you have x can be negative, right? Modulus of a sub n plus 1 on this one. So right, you get something like this. When you simplify that, you get something like this. So if you this one here, so when you consider the limit of this one, so n goes to infinity, what happened? The denominator here, denominator goes to infinity, so 1 over something big value go. So this is negligible, then e to the, so this term goes to 0, so this power goes to 0, e to the 0 is 1, so this term goes to 1 times mod of x. So from the ratio test, if this limit is less than 1, what happen? You can say that this series is convergent. If this limit is greater than 1 from the ratio test, right? You can say that this is divergent, right? So the radius. So now you consider endpoints. We don't know about the convergence at positive and negative 1. So we have to consider it separately. So when x is equal to 1, right? So you get this. What happened to this one? This term. So this is your a sub n. This one goes to infinity as n tends to infinity. That means, so if this is convergent, definitely an goes to 0 as n tends to infinity. Otherwise this infinite series is divergent, right? So because of this series is divergent. So if you look at the case, this case x equal to -1, so you can similarly you can say that this is also divergent because this term does not converge to 0 as n tends to infinity, right? Therefore, the interval of convergence is this, and radius is 1, r is 1. So now we go to third part of 7th question, right? Summation n goes from 1 to infinity, factorial n to the power n factorial n cube divided by 3n factorial, this power series, right? So let's first use a ratio test, right? You can compute this modulus of these two consecutive terms, right? Can compare, you get this something like this here. So here you have n plus 1 cube, and here you have linear 3 terms of linear term, 3 terms of 3 linear terms here. So linear term, linear term, linear term. So when you take the limit, right, this becomes the limit of this one is equal to 1 as n tends to infinity, right? So no, you had to take this 3, so this is constant in front, then you get 1 over 27, or this one, the limit of these things is equal to 1, right? So finally you get this, here modulus sign is missing, so let's add that modulus sign. So from ratio test, if this one is less than 1, the power series is convergent, and otherwise greater than 1, the power series is divergent. So now we consider two endpoints. These are the endpoints. What are the endpoints? 3 cube and negative 3 cube. So we consider these points separately, right? When x equals 3 cube, we sub this one into the power series here. So what you get? So you get something like this, factorial n cube 3 to the power 3n divided by 3n factorial. So now we consider the binomial expansion of these two terms. The binomial expansion of this one here, and this one is same with 3 to the power 3n, and this one is I think this is similar to previous question, right? So this is one of terms of the binomial expansion here. These numbers are positive, so this is positive, the sum of positive numbers. You don't worry about negative numbers here because these are positive numbers. This one also positive, this one also positive, right? So the whole binomial series is bigger than the single term of binomial series, which is this, right? Then you can show that this one pretty easily. Just go through this note here. You can understand this one here. What you can say, all terms of that series is greater than or equal to 1 for all n. This one is important for all n. All terms are bigger than 1. That means, so this term does not converge to 0, right? So this series is divergent, and also you can consider negative other point and similar case. So therefore the interval of convergence is this. The radius is r is equal to 3 cube.